Okay. Yeah, so Bitcoin Relay Network. This is not a talk about block compression necessarily. I know some of you might have been expecting that. This is more a talk about centralization pressure in how we relay blocks in general. I think Rusty's going to talk a lot more about some of the fancier block compression schemes that a lot of people have been working on. Do I do it? Whoops. Okay. So the relay network started a year and a half ago, 2 years ago now. And at the time, there were really two big concerns that a lot of people had in the Bitcoin ecosystem, at least that the relay network was trying to partially address. The first was the number of listening nodes across the network was drastically declining, which is indicative of two issues. First is that a lot of people are reducing their security model and choosing to not validate fully Bitcoin so that their payments are potentially significantly less secure. That's not really something the relay network tries to address, but it is a major issue. But the really big issue with number of listening nodes decreasing that the relay network can sort of address is that this decreases the network's resilience against attack rather significantly. So if we only have 100 listening nodes, then there's only 100 mostly VPSs that you have to go knock offline before the network starts to become really hard to get connected to, really hard to, stops working, mostly. This is potentially really easy because knocking off 100 or 1,000 nodes is actually not that hard. So the relay network is a pseudo-alternative. It's not designed to be as efficient, at least for getting everything out, and it's certainly not something you can sync from initially, but it's like a pseudo-centralized second network that you can connect to. Another big issue, and this is really the larger motivation for the relay network, was at the time a lot of people were worried about the selfish mining attack. So I'm not going to go into detail about what it is, but essentially the paper claimed, and it is mostly true, that you can, with 33% of the mining power, essentially pull off a short-term 51% attack. And this is much easier, in fact, and you can do this with significantly less mining power if you have better visibility into the way the network is laid out and you have better connection into the network than anyone else. And at the time especially, and in fact even still today to some extent, we have very little visibility into the way the network is laid out. And I know there's some people here who have done really good research trying to figure this out and trying to map it out, but still there's a lot of potential for someone to connect both smartly and to a lot of nodes and get much better visibility into when a block is announced. So yeah, the relay network can sort of address that. I'm going to get into. So basically what it is, when it started, it was just a bunch of random nodes around the globe that are trying to get a bunch of miners to peer with it. And this seemed to work pretty well, right? We can get a bunch of miners connected and it doesn't filter blocks, which means the selfish miner, you can't gain an advantage because everyone's just connected to the same network, or at least the same network has good connectivity. And especially for small miners, right? If you're a big miner, you can potentially gain a big advantage and pull off a selfish mining attack or something. But if you're a small miner, you don't have time to invest to build a giant relay network. So it started as just some centralized nodes that just did SPV validation and relayed things quickly, but that actually wasn't very quick because Java in a low latency server environment doesn't work. So now it is much smarter. It does some pseudo compression where it takes each transaction in a block and just says, oh yeah, instead of sending the whole transaction, it can just say, that transaction I sent you 5 transactions ago, yeah, that one. And it does pretty well. So these are two graphs. One is when I gave this talk a few weeks ago, and the other one is from the last 2 days. You'll notice they're very different. So the yellow line is the actual block size, and then the red jagged thing is the amount of bytes sent over the relay network. In general, when the network is functioning normally, the graph on, I guess, your left is what you'd see. The one on the right is because right now the network is filled with a lot of spam that all has the same transaction per kilobyte rate, or fee per kilobyte rate, which causes some problems, and there's some issues filed on GitHubs, and you can see it's not actually trivial to get rid of. You kind of have to rework the way mining is done in Bitcoin Core slightly. So This is a map of the various nodes in the relay network. And it's very interesting because I had to spend a lot of time to come up with this topology. It's actually not trivial. So routing in Asia is generally terrible, especially into mainland China. If you're routing from mainland China to almost anywhere else, essentially it goes through Japan and then LA. So if you're not in Japan, you're not going to get it. And if you're trying to get to Europe, you don't want to go through the US. Turns out there is a cable through Siberia, but the only way to get that is if you have a node in Siberia that you can route through. So yeah, I had to spend a bunch of time figuring this out. And small miners are not going to do this because they don't have time to figure this out. Big miners might because it can potentially save them significant orphan rate. But peer-to-peer network is not going to find a quick route from Beijing to Amsterdam through Siberia. This is not something that a randomly laid out network is necessarily just going to figure out on its own. So there's a big tension here, right, between a distributed network that we can just throw nodes at and it can relay blocks quickly, and something that's going to shave off tens of seconds and several % of orphan rate because it's centrally designed and centrally planned and actually works well. So yeah, there's a huge opportunity cost to just not using this style of centralized network. Oops, this got cut off. I don't know what that says. Anyway, so this is a wonderful graph of time to relay things around the network. And this is really relevant for block transmission around the network because you can see on they're both log axis, but on the left axis you can see, and the vertical axis you can see the block size that's actually sent over the wire, only up to 1 megabyte. And on the bottom you can see how many milliseconds it took to get around the globe. And there's a very strong correlation after you send a few packets. And the relay network often sends things in 1 or 2 TCP packets. But after you get past that, you start to have a very strong correlation. And in fact, this is indicative of how TCP behaves across long-haul links. And as it turns out, it has nothing to do with the fact that all of these servers have gigabit links or 100 megabit links directly to backbone connections. It actually just has to do with the latency and the packet loss. Once you lose a packet or two, things start to slow down rather significantly, and you end up with a few RTTs. And by the way, that 10-second that you see all the way on the right side, that is 1.5% lost revenue for miners, which is rather significant. So yeah, I'm also here to ask for help because this project is something I've been running by myself for quite a while, and I would love for anyone to contribute. There's a GitHub, there's easy issues file that you can go read. It's pretty simple and it improves the effective hash power of Bitcoin just with software. Also, there's a roundtable on network propagation later. If you want to dive deep on all of these issues, including all kinds of crazy compression stuff with Rusty, he'll be talking in a minute. Definitely come to that. Yeah, thanks.
Test.